The one that, remember I told you something.
Hi guys, good morning. Can you all hear me?
Yeah, good morning.
Yeah, good morning. Yeah, so we're able to wait for 10 minutes for others to join. I think we can get started now. Others
All
will
right.
join along the way, and we've started streaming on X already. Hi Mario, good morning.
Morning.
Yeah, we are happy to have you here today. So sorry for the delay. We're waiting for others to join. Yeah, you can get started with us this
So
morning.
I can share my screen, right?
Yeah, you can. I already made you the co-host, so you have access to that.
Okay. Second. Oh, it's very hard for me to see what's happening here. 1 second. It doesn't actually show what I need to share. 1 second. It's a bit weird. That's why. 1 second. Apparently, I don't have. I haven't used Zoom in a while, so I apologize. I have to re-enter the meeting. 1 second.
Hi Mario, would you like if I help you like share your screen from my side? Maybe you send your slides to me.
My slides.
Oh, I don't think he's on the call. He left. Oh, he's still on the call.
Sorry. I'm here. I had to restart because it couldn't let me share because of the, I had to give access for some reason. Thank you. Okay, now I can see what I'm sharing. Perfect. Oh, lovely. Let me, this one, yep. Okay, can you see my screen?
Yeah, yes, we can.
Lovely. So, hello everyone. We are here to do a workshop on Solana and Solana common bugs, basically. We are gonna, in today's basically workshop, I want to tell you guys about most common bugs that usually appear whenever you build Solana programs. And we are gonna focus on one of the most used frameworks in Solana, which is Anchor. For those who do not know what Anchor is basically a framework that lets you that's doing an abstractization over the normal Solana code, and that it gives you basically a lot of predefined checks already. But even though it gives you a lot of predefined checks, it does not mean that it keeps you safe, right? So that's what we are going to focus on tonight. Let me open also the chat here, so in case someone writes something, I can see. Okay, perfect. Awesome. How we are going to go about this is super simple. I'm going to show you some bugs that are not so obvious in Anchor, and then we are going to discuss a bit how and why those happen, right? So the first actually bug is a simple one. We have here a simple Anchor Solana program. As you can see, usually when we are talking about Solana, we are talking about two types of accounts, right? Data accounts and program accounts. Data accounts are the ones who keep the data itself, and the program accounts are where the logic happens. To put this in like simple terms, the data account is more like a database, and the program account is more like a algorithm that does something, right? Now, in our example here, we have a simple counter program with an increment instruction. So this is the instruction, and then let's see what the logic does, right? The logic is pretty explanatory. We have a context increment that does a count that counter that count plus one. So if you look at it, it feels pretty simple, right? It has basically it's altering this data account count with it's incrementing it. It looks like it's super simple, like there is no bug, but unfortunately, this is the first bug class that happens in many of the programs out there. Someone is unmuted, sorry. I have someone. Okay. But in fact, we have a bug here, right? And the bug is that we are missing ownership check. What does this mean? So the ownership check is one of the most actually ugly bug that happens in Solana programs, especially also when you are using Anchor. Why this is the biggest attack vector that people are looking on is because accounts, I mean, in order for you to modify accounts, you have, of course, to be the owner of that account or be some sort of a delegate to modify the data, right? Well, here, because you are missing this ownership check, a bad actor can just take any counter and exactly anyone, perfect Collins, anybody can basically increment this counter, right? You look at it, it looks safe, but in fact, no, because I can provide you Collins basically account and I just increment it. The example that I'm going to show you throughout this workshop, they are simple, but you have to do a bit of abstraction and think about, in a real life scenario, how bad that is, right? In this case, of course, it just counts this counter, but in a real life example, may, for example, steal funds from your vault because it can modify your vault account. How do you usually protect against this? It's super simple. You have this has one authority, which is a very powerful macro built in the Anchor. As you can see, we have a field authority who basically is the one who should modify the account. And now by doing this constraint of has one authority, what it does is actually, let me see if I can do this. I think I can draw. Perfect. It's actually matching this one with the authority from our account. So this will basically translate to increment authority to be equal with basically counter authority account. So by just having this little, check here, right? it actually provides us a powerful, it provides us a powerful constraint that protects our program. So as you can see, a simple, exactly. We just saved our protocol billions of dollars just with one line, this simple line, right? It actually looks so simple. And I know some of you may think right now, like, yeah, but everyone does that. Well, in fact, I cannot tell you how much I find this as a bug in many, many protocols. Like these missing checks, like who actually can modify an account, it's a very, very common, unfortunately, in instance. That's why I also decided to provide it here. This is just one. Let's go to the second now bug. Oh, wait, I need to erase this. Sorry. Perfect. Now, look, going back to the bug number 2. We have the same counter, as you can see. Again, count authority. Right now, we actually has one authority, so we are kind of safe. So the authority actually cannot modify any type of account. And it actually looks pretty harmless because it looks the same, right? But the problem is actually super simple right now. Is the fact that, well, what happened with the authority? Previously, authority was a signer, but right now it's not a signer. It just requires to be account info. What does this mean? It means that we did not require for the authority to be a signer, which means that the authority did not give the permission to modify its account here, right? So that means, again, going back to the same attack vector, is that anyone can modify any account, even though we have this has an authority. Again, a very simple and very dangerous check that was missed. So now, by just doing a simple, basically, by just doing a simple signer, basically definition, we told to the transaction creator to sign this transaction so he can modify only his account. Going back to also what Colin said before, was that just a simple modification. Exactly. The authority was involved. So right now, when you look at this without, the signer, our basically example here, right? It's super simple that you can look at it. Yeah, it looks safe because the authority cannot modify other account, just its account, because it has one authority. But because it was not actually a signer, it meant that that authority did not give consent. So I can just get any authority and its account from anywhere and just, again, increment it by 1. So a simple change like this, right? A simple change from the account info to signer, we just said that right now the authority has to give consent, of course, to modify its account. Simple check, again, missed, boom, $1 billion gone. Very common attack vector. Unfortunately, that is still happening. Yeah, we saved another 1 billion. Okay, by the end of this workshop, we're gonna save some billions. So thank God I am doing this workshop. I'm joking. Now, bug number 3. Let's look at this. Seems a bit more complicated. So we have counter account, we have has one authority, we have authority sign. So everything looks good actually. We have the system program, okay. And now we initialize this account, right? We initialize the counter account to the authority and set account to 0. Okay, nice. Which means that it looks pretty safe. I mean, I'm just creating this account, as you can see, right? So it's an account that I can create it, and I set the authority, and I set the count to 0. Well, but unfortunately there is a bug here. It means that, as you can see, anyone can initialize this as many times as you want. You have no constraint on how many times you can call this thing. Because this is an initialize, looking from a business point of view, it means that it should be initialized just once, right? But because we do not have any check anywhere here to check that if this authority actually, if this counter account is actually initialized already, it means that me as an authority can initialize over and over and over again. Now, put it into a more broader perspective. Think about, I don't know, another program that looks at this count to give out some funds, right? Because I can initialize it over and over again, I can easily reset this count to 0. The solution is pretty simple. It's actually it's actually, we have to use at the counter account here, we have to use an init. By using this constraint here, we tell to Anchor that this account must be initialized just once. What this means, it means that this account doesn't exist yet, but we actually create it here, right? And initialize it just once. So that means, because we create it here and we have this constraint added to the counter account, it means that right now this account can be initialized just once, and Anchor behind the scenes keeps a count for that. Which means that if you will try to call again this instruction to initialize, you will fail because this account was already initialized. This is a very common DOS attack. Exactly. Free trial, that's a good example. Collins gave a very good example. Like, let's say you have a free trial application that should last for 30 days, but because you could reset this counter at any time, you basically could get again 30 days of using this application. But because we have this init, it's very, Anchor basically protects us. Now let's go to the next bug, which is, now we assume that we want to call increment, but we don't care when the account was created. We just want to perform an increment on it, right? So this is the case because this is a common DOS as well. Here in this example, we have init, right? We have the counter account, we have the signer, we have everything, and we actually do the count +1, very nice, but we cannot hold this every time, right? Why? Because I told you previously, the init, it lets you basically create this account just once. In our example previously, we wanted this increment, the initialize to be called just once, but here we want this to be called many times. But we also want to either create the account or actually have it right now created. For this to be successful, we need to basically have, a specific instruction, which is this one. Oops, sorry, not this one. Come on. Why this doesn't work? Okay, sorry. It's a bit confusing because I have to clear everything. Perfect. So I need to use init if needed. Init if needed is very important because if I use just init, it can DOS. Why DOS? Because I can then call it just one time, create the account, assign this, and that's it. Well, this is again another common DOS in Anchor and Solana, is that people misuse the init versus init if needed. Init if needed, as the name already tells you, he is initiating this account like it's creating it only if it's needed. So if the account was not created before, it will create for you, but if it's created, then it lets you do the count on it. Again, very common attack vector and DOS vector in Solana. The misuse of init and init if needed. So whenever you look at or you create a program, you have to carefully choose these macros, because even though they look, they can protect you a lot, they can also create harm in most of the cases if they are not used properly. Now let's go to the account and bug number 5, which is basically a PDA collision. Does any of you know what a PDA is? If not, anyhow, I'm going to explain to you what it is. A PDA is basically an account that is predefined by using some seeds, as you can see here, right? So in our example, we have 2 accounts. We have product account and we have the bid account, right? And the product, it's using a seed for the PDA creation of product and then product name. But then the bid account, it's using the product name as the seed plus the user key. Well, there is one problem here, which the problem is that even though this is this seed creation is somehow safe, because you cannot create 2 accounts with the same seed, an attacker can actually use this to weaponize it. In our example here, as you can see, we can actually take advantage of this product name to actually DOS the bid creation. And how this happens, I'm going to give you an example here. For example, if we have these 2 products, right? We have the product and then we have the product with the name "you should buy this product fast," right? I can create a bid like this, and then DOS anyone who wants to create this product. So it's very PDAs are very, very useful, but are also somehow exploitable. Why? Because you exploit the one trait that they are also very useful for, which is the being deterministic. Because they are deterministic, it means that I can predetermine what their address will be, and I can actually mine some of those values until I manage to collide with one of these PDA, right? This is an attack that is more sophisticated. It's not so common, but it's one of the attacks that I wanted to show you because they are a bit, different than just a normal missing stuff. Here actually we go a bit more deep into the attack because the attacker has actually to fuzz these seeds so he can manage to get one seed for a product here that will actually crush. So it's a very interesting attack vector, and you should look at it. It's called PDA collision. If you want to look more into it, feel free to do it. Now let's go to another type of attack, which is super interesting, which is called the revival attack. Well, what does actually mean a revival attack, right? Well, accounts in Solana and Anchor, of course, can be closed. Why? Well, it's super simple. When you create an account, you have to pay the so-called rent. What is that rent? It's basically a fee that you pay for the Solana to create that account for you. Now, sometimes you have to close those accounts. What does that mean? It means that you have to close them because you want to get that rent back, right? How can that happen? How can that be weaponized? It's super simple. People don't understand how close works sometimes. And on the left, we have the exploitable part. And this happened in the past. Actually, this also was a known exploit on Solana, which I forgot the protocol that was exploited like this, but if you search this revival attack exploit on Google, you'll probably see that there was a known exploit which weaponized this revival attack. And let me explain you how it works. It's simple. Whenever you want to, so Solana has the so-called garbage collector. What is the garbage collector? It's like you're looking at the final of the transaction, and if you actually deleted, basically wanted to clean an account, it will actually clean it for you and destroy it. But what are the properties for that to happen is that if it has no data and you transfer all the lamp ports outside, as you can see here, I transferred all the lamp ports of this account to another account, right? Then the garbage collector is looking at it and is saying, okay, this is safe to basically destroy it. Well, the revival attack, it's actually cleverly exploiting this. How? Well, let's think about this, right? You have these redeems rewards of a lottery, right? And what it does is something like this. You redeem these rewards, and then it closes it. So because it was closed, it gave you the rewards, and everything is fine. But because I can use the revival attack, which I can revive this account so I can redeem them again. How is that happening? Well, as you can see here, I sent out the, let's assume the account is empty, but I also sent out the lamp port. So if we're looking at the Solana, how it works, the garbage collector should actually, at the final of the transaction, should clear this account for me. So I should not be able to actually use it again. Well, there is one small thing that can be exploited here. And the fact that how garbage collector works, because it's called at the final of the transaction, it means that I can have another instruction who revives this attack for me. So usually an account, so like a Solana transaction is like this. This is the transaction, and we have basically like this, for those who don't know, just to provide a bit more context. So we have instruction 1, instruction 2, instruction 3, and so on and so forth. So this is basically a transaction, right? With many instructions. An instruction is basically, in our example here, is redeem rewards in security. It's an instruction, right? So as you can see here, an attacker can weaponize this logic with the logic of garbage collection to do the following stuff. In instruction 1, I redeem rewards in secure. In instruction 2, I send lamp ports back to this account. So now, in instruction 3, I can actually use that account again. In instruction 4, and so on and so forth. But at the final of this transaction, the garbage collector will see that I will have actually lamp ports into that account, so it will not delete it. So it's super simple and this is how the revival attack works. It's basically weaponizing the fact that if you do this, right, you think you are safe, because according to Solana description, if your account has no lamp ports and has no the data basically is empty, then you can close it, but that's not true always. You can close it just in that instruction, but also if at the final of the transaction, so this is the transaction, right? So this is transaction, and this is instruction, right? Let me write it here, instruction. Oh, can I move this? Okay, I can move this. Yeah, so this is an instruction, right? This is an instruction, and this is the transaction is basically this thing. And I can basically weaponize that. How do we solve this? Well, if you're using Anchor, it's super simple. by just using this small close, as highlighted here, if by using this close macro, Anchor is actually, it's smart enough to close the account, but they do something else. They set a discriminator to it. So if you try to revive it, it will actually not work because Anchor won't be able to use it anymore because it will have this discriminator of close. So this not only clears the account, can sense the lampwords and so on, but also that's like a marker to that account to know that it's closed. So if you try to use it again, you won't be able to use it anymore. It's a clever attack that it's exploited most of the times. But by just using this small thing in Anchor, you actually get protected now against the revival attack. Let me clean this. Let's go to the next. The next one is a very simple unsafe CPI calls attack, which is an interesting attack. So a CPA, you can say it's kind of like external call, right? It's an external call to an outside program. Whenever you want to interact between two programs, you have basically to CPI to use this CPI, which is basically a external call to the outside. Now, while this offers a lot of, this is a powerful feature for you to integrate between many programs. For example, token programs that can let you transfer tokens from one to another. It's also very dangerous because you have to carefully check the arguments that you send to the CPI call. So in our example here, if we look closely, we have basically a CPI call that calls, right, this destination key with this user key, right? And you call this program with this destination, right? The problem is that this destination actually is not verified at all, which means that it can be any destination. So it's an input that we should never trust because it can be anything that you want. So you thinking that you are actually sending the accounts to a safe destination, in fact, your destination is malicious. And what you should do is you actually should verify all the time these accounts that you call to the CPI, right? For example, in our example here, we check that this is an expected destination, right? So we don't have the destination. We just assume that the user is not malicious, and they will put this destination as as an account. Here, we always must assume that the user is malicious and they can put dangerous inputs here. That's why we always have to do the checks. And I want to check here example. Of course, this can be mitigated in many ways, but one of them being the fact that you can actually expect and check that this destination is an expected key that you want. So you won't let the user choose whatever random destination they want. CPIs are super nice, but they're also super dangerous. And now this is another CPI call that I want to tell you, which is again a missing check. So again, I put this here just because I wanted to make it, clear, and I wanted to repeat it over and over again because this is very, very dangerous. Inputs we do not verify are always dangerous. So your job as a developer, as a security researcher, as someone who looks at a piece of code, it's always to make sure that the inputs on a program are not safe. So you always have to have them verified. Now, in our use case here, of course, let's see what we have. We have an authority, we have a source, we have a destination, and we have a token program, right? what we do a withdraw, as you can see. So you actually call withdraw token program to a source and a destination using this authority. The problem is that this token program is not a token account verified by Anchor. It's actually an account info. What does this mean? It means that I can provide any account here, which in fact, as you can see here, is doing a CPI call via transfer to it, which means that you as an honest developer, you thought that your users will input here a token account, but they actually can input a custom fake token account, which in fact can drain you, for example, for more tokens that you expected. It's very important. Again, this is just because it's transferred to the CPA. CPA looks is very useful, but it's also very dangerous. That's why we should always verify the inputs. So inputs that we do not verify are always dangerous, right? Let me clear this. This is token account 8. Sorry, bug 8, which is related to the token account. When first Solana started, they created this SPL token account, which are token accounts that basically let you have a balance, transfer accounts from one account to the other, which was very useful. But in 2022, because also the name says here, they developed a new token account, which was called Token 2022. And this was supposed to be a new type of account that has more, that has more capabilities than just a simple legacy SPL. The problem that arrives right now in the Solana community is the fact that now you have two standards that you have to deal with. So you have a SPL token account, but you also have a token 22 account, and they are not the same, right? Of course, they are not the same, because then why would token 22 be created? But what can happen right now in our examples is that right now our example here tries to transfer from an ATA, which is basically a token associated token account, to another associated token account, but it's using an SPL transfer. What does this do? It means that I can only use SPL, legacy SPL. But there are use cases which you actually need to accept all types of tokens. And let me give you an example. You have a NFT marketplace where you want people to pay with, various tokens for your NFTs. Because in our case here, we have just SPL transfer, it means that I'm not able to use token 22 types of accounts. So right now, this is the business logic that was actually it's a bug in the business logic itself. Because from a business point of view, you want to accept any type of token, but because you did not know that this SPL transfer, it's only used for the legacy SPL, it reduced the amount of token types that you actually can use. So it's very important, again, for you to understand how these are performed. And unfortunately, this is, again, a bug that happened over and over, especially when these two types of tokens started to use. Right now, they are less. It's happening less, but it's still a big, unfortunately, bug in the Solana community. So you have to, again, think about the business from the business point of view as well, not only from the legacy point, not only from the dev point of view, also from the legacy, from the business point of view. Let's see the next example. Unfortunately, the last side that I have, it's actually the one that I cannot teach you how to solve it, which is the fact that the first security risk for Solana programs are still faulty business logic and missed edge cases. These are basically logic issues that are introduced into the programs, and no framework or anything can actually protect you against this. But we have some defense layers that we can do to improve our, let's say, our security of the programs that we write. First, I recommend to everyone to have like continuous rigorous peer assessments, like have someone that did not write this code to look at the code and give opinions. So usually this is a colleague if you have a team of two, or you can hire an outside developer just to look and give you like an initial assessment. Testing, having a comprehensive unit testing, end-to-end testing, edge case testing, very important. It's very, very detrimental for your programs. Like even if they look simple, sometimes the bugs are actually there. As you can see in the first 2-3 bugs, we had simple bugs where you just did this, we missed a simple check or a simple constraint. Fuzz testing, which is a more advanced technique, which is basically lets you fuzz a specific account, a specific logic, so you can see if any edge case was missed. And of course, security audits, which is usually someone that we recommend to everyone, just have an outside party who looks at the bugs and discovers bugs day by day, so they can look at your basically programs. And the last one, which is a very nice one, but it's also a very costly one, which is the formal verification. This is basically a mathematical proof of correctness of your logic. This is usually what the big protocols in Solana are doing sometimes. Like, I don't know, some of these like AMMs that are holding lots and lots of money are doing this, but it is also a technique that takes a lot of time, because to mathematically prove everything, of course, it will take, it's a monstrous, basically, it's a monstrous job. And with this, it concludes my my presentation for today. And I want to basically leave you with this. Even though it looks simple, it's sometimes actually not that simple, and it can actually have a lot of, you can have a lot of problems. So whenever you write or you look at the code, don't try to say that, okay, this is simple and doesn't look like it has any bugs, but in fact may have a lot of bugs. And I hope it was helpful for you to understand a bit how you should look at the Solana programs and how you should start to try to investigate the area that can have problems. So if I may say, some of these are like accounts all the time, CPI calls, and tokens are basically top 3 things that you should look at every time and try to look a bit in details.
Thank you so much, Mario. We really appreciate this workshop. It was really, really amazing. And I'm sure every developer here learned 1 or 2 about being security conscious and the risks that are involved in writing Solana programs. I really did enjoy this workshop a lot. Thank you so much. Yeah, thank you very much. The slides for everyone for everyone asking about this slide, we'll get it for Mario and we'll post it on the Ag Resources channel. Aurelia, you had something to say, right?
Yeah, that was what I wanted to say. So Mario, please help with sending like the resources to the Telegram and the slides you used today, so the participants can use it afterwards. Thank you so much for your.
For sure, I'm gonna do that.
Yeah, would you like to get questions from them if they have questions?
Oh yeah, that's true.
Yep, please.
So if you have questions, you can ask.
You can raise your hand or send it in the chat box. Take 1 or 2.
It's fine if you write them in the chat as well. I can answer them really quick and I can tell them. So it's fine. Just
Okay, thank you very much.
drop the questions. So any questions so far?
Guys, it's your time to ask questions. Collins, if you have any, you were active, you've been active in the chat box. If you have any question. Adiola, what about you? It seems there are no questions. Maybe it will take time to digest it and understand the material well.
Yeah, maybe after using the resources, they'll send their question in the Discord.
And they could send it in the Discord.
Yep, for sure, for sure. If there is any question, okay,
Oh,
do
we
these
have a
bugs pop up?
question. We have it.
Yeah, I see. Finally. So, do this? I'm gonna read it out loud. Do these bugs pop up when with a different framework? Say when you are not using Anchor. Yes, but they appear under different form, right? Like account checks, they can still happen if you use Pinocchio, like if you use raw Solana programming, but they will not be just as simple as constraint. They will be actually, from a logical point of view, you miss a check that you should perform. The reason why I put Anchor as the example is because sometimes people think that by using Anchor they are safe and they should not do any check. But when you don't use Anchor, it's actually even more dangerous because Anchor anyhow does checks for you. But if you don't use it, you have even more problems. So it's more complicated actually if you don't use Anchor. Anchor for now is the most secure way to write programs right now. Any other question? Let's see. Okay, no worries. My pleasure. I hope. I mean, the reason I'm doing this is just for people to write secure programs.
We have a question.
Adele wrote, there is a lot to take, but then this way the techniques lead to the front end if not manager. I'm not sure exactly understand the question. You mean that what happens if the front end gets exploited, you mean? Maybe I didn't understand exactly.
Oh, you said yes.
Well, that's another problem, which is the fact that sometimes you prepare so much for the programs, but the Web 2 part of the product that you are building is not so well prepared. This is the Web 3 part where it's something that you deploy on chain, but the Web 2 part, which is the part where you keep the front end, you deploy your backend if you have any backend, your social media accounts, those are not protected enough. So then you get leaked and you suffer another breach there. But that's a different, it's a different perspective. It's not necessarily related to Solana. It's related to day by day business operation, basically. I put the slides in the chat. I'm gonna put it on Telegram as well. No worries. But I also put it in the chat for your team. Okay. I think those are all the questions.
All right. Thank you so much, Mario, for your time. I mean, if you guys enjoyed the class, let me get reactions. Okay, we have a question from Collins also.
Keep up the eyes on the social. It will be soon.
Okay.
Collins, no worries. Thank you, team, and have a nice one, and good luck in your endeavors.
Yeah, thank you so much, Mario. Yeah, thank you so much.
Bye-bye. Bye-bye.
Yeah, bye. Thank you. Hi, Larry. Do you want to continue while we wait for our tutor for the next class?
Sure. Okay. Give me a minute, please.
Yeah, so the resources will be shared for sure after the class on the Telegram group chat. So yeah.
All right. Good morning, guys. For those that were not here when I said good morning, how are we all doing today? Hope everyone is having a great day, and I hope this workshop was actually very chill. This is probably one of the first technical workshops I know I definitely have to go back in the sense that I did not really grab everything at once. I mean, it made sense. It made sense at some point, and at some point I was like, "Oh wow, I don't know much." So, but the fact that I was able to learn how to be security conscious with Solana contracts and writing Solana contracts, it's really nice. But I guess one of the people I want to I don't want to say single out, but just talk about is Collins. It was like as if you were in your domain. Tell us, for how long have you been writing Solana contracts? Um, if you
Yeah,
are
for
coming
real.
to the chat now,
I was so shocked. He was so proactive all through. I was questioning. I was like,
exactly,
I hope
it
this
was
guy
very
is not
very
going to
proactive.
clear his screen at this point and also teach us.
It was very proactive. He said to us now, I don't believe that. I don't. It's a lie. It's a big lie. Because there was one example he gave, right? The one about the 30-day free trial. And I was like,
Yeah,
I
exactly.
was like, okay.
Should we prepare another prayer workshop for you tomorrow,
Yes,
Collins?
yes,
To teach us?
yes. I think we need another track for him, just him personally, because it is no. But it's very nice. It's nice to see that at least there are people. It's not just for beginners, right? You can also come in if you're a student, come in and show what you have, can build ideas, everything like
Oh,
that.
you said you took the blue shift course.
Oh, really? And
Must
that's
be a
very.
smart.
But wait, you took it when this and when the pre-hack workshop started, or you've taken it before? Um,
Yeah, so it seems like
Colin.
our tutor is here already. Hi, Daniel.
Right.
Good morning. Can you hear me?
Daniel.
Yeah, Jam guys, can you guys hear me?
Yes,
Yeah,
we
yeah,
can.
Yeah, I was trying to fix the mic. My speaker isn't that loud. 1 minute, please.
Collins, please leak it, please. I'm looking forward to it.
Some new things are pretty cool. This is
Okay, so I'm trying to get. I guess I have to disconnect this. All right, so GM guys, hope I'm audible. All right, nice to be here. So a little introduction, because we have a lot to do. So my name is Daniel. I am an engineer. So I build mostly with Rust and Solana. I've been an engineer for 4 years, 4 years, 5 years thereabout. Turbine grad, uh, 4-time Turbine grad. Um, um, Graduated from the builders cohorts as well as the advanced SVM. And then right now I'm currently working on building my own game. called Rust Undead. So Rust Undead is like a gamified way of learning about Solana, similar to Crypto Zombies. If you're around crypto in like 2017, 2018, it's similar to Crypto Zombies. So and so far so good. We've been doing a couple of amazing work. So nice to be. I'm actually glad to be like talking to you guys here. I can see some familiar faces and really happy to start. So I am going to share my screen so we can get to what we have. How do I do this? So yeah, so this session is gonna be, yeah, what of the screens did I share? So I'm actually not very conversant with it. So mostly I do Google Meet. So I might be doing like an old man. All right, so yeah, so let me just present this and we are good to go. Right. Okay. All right, so can you guys see my screen? If you can just thumbs up, wave. Yeah. So today we'll be looking at AI agents and on-chain interaction. And for demo purposes, we'll be building a campus chatbot with Solana, a project I called I kind of gave it a name, Nebula. So it sounds funny, but so we're going to look at Nebula and how Nebula is going to help us check our campus spending. So, for example, if you're doing spendings around utility, um, let's say you mostly use maybe let's say, for example, air bills for utility. So you can check, okay, how often do I spend on utility? How much do I always spend? When is my next spending based on my interaction? And then you can also off ramp directly from Nebula. So still a work in progress. The AI world is kind of new on chain, so it's a lot of broken tools, a lot of things to like fix. And but I actually pulled up something that I can present right now, and then in the evening we can like take a deeper dive, right? So I would first go with the theory, explain what we're doing, explain all the integrity parts, and then take a first look at the um first look at Nebula, right? Connect our wallets. So just a little info. So we are working with Privy for seamless connection. So you can connect your email, you can connect your wallet. I need to fetch your wallet, fetch your balance, fetch your transaction history. And from there, you can like shoot a chat like, hey, can you transfer or make a payment for electricity? I'm like, okay, how much do you want to make? So right now it's just routed through one of my favorite utility providers, which is Bills. So you can like check out your USDC to pay for utility or get airtime. It's still a work in progress, right? So a little bit of stuff and there. But at the end of this course, I think everybody should be equipped with how to do that, you know. So first of all, let's just get started. I've already done the introduction. I don't know why my image is not loading. Yeah. Okay. Yeah. It is. So I've given the overview, right? And I said we're gonna look at the foundations and setups and environment configurations and how to get like the AI environment into Solana. How to set up um your environment, your code, and configuration with like popular LLMs like OpenAI. Actually, for the sake of this event today, I am actually using OpenAI. So I will show you guys how to set up OpenAI AI too, so you can look at it and then know what to do. So we also build the blockchain connection. the proper way, and then fetch balance. So you'll be able to get your balance, and then you can basically do a lot of stuff with it. And then LangChain, talk about LangChain. I know with my other colleagues have talked about LangChain, and also it's going to be used here. But we are not going to go deep into it. We're going to look at it and then look at what's possible on Solana, right? So what are the provisions, which is why I had to include Send AI. So I will talk about Send AI too. And I mean, it's a lot. It's a lot, yeah. But so let's just get started. Also implement stateful conversations so you can like have a conversation with the AI. Not really fluid right now because of like how you have to like train the models and get it to like follow the train of context. When you say context, you mean if you are talking about spendings and utilities and like off-ramp, so that's the context that the AI would follow, and you have to tell it, this is your boundary, this is your limit, this is what you have to do for me, so it doesn't go beyond that. So there's a lot of work. I mean, when I got the topic, I was like, oh, this is something I can play around with. But digging deep into it, I realized that it's more work to it than just what the name implies. So also look at the objectives, so which is Nebula. I'm sorry, I did not update the name here, but we'll be looking at Nebula. So Nebula connects to Solana via Privy. I already mentioned that. Analyzing does your analysis on your spending patterns, right? So you check your balance, basically Sol and USDC, and then get your transaction history. And as I said, we are picking two utility providers, right? So that's why I mentioned off-ramp and utility payments. So we have a way to like check your interaction with these two addresses, two products and their addresses, and like, okay, you spend a lot paying for electricity. Do you have maybe you consume a lot of electricity, right? Or you off-ramp a lot every Saturday? Are you a party person? Do you always like getting it on Saturdays? So stuff like that really that's like the aim of Nebula. And building Nebula would actually span more than like after this today. So we'd actually try and make it to be something like standard and share with you guys so you guys can use it. You guys can, play around with it, possibly even like allow it to help you run your utility payments and stuff like that. So I don't know if I'm audible, guys. I'll be doing like a check every time just to make sure I'm not lost. So are you guys still with me? All right. Good, good, good. So let's go, let's go, let's go, let's go, let's go. So first of all, the core of what we're doing is the AI agents, right? So from here, what I have here, they are autonomous software programs that can perceive their environments, make decisions, and take actions to achieve a specific goal. So the environment, which is what you as a developer would tell it to do, because we have to see ourselves as people building this AI chatbot. So we have to give it limits. For platforms like cloud or yeah, cloud, for example, is more code driven. So the context for cloud is more of like code. So for developers, you can troubleshoot with cloud. You can even see when you prompt with cloud, you would see that it formats your code properly, the way you can actually interact with it. You get, and then for others like ChatGPT is more of like a general utility that is seen in. Can you guys hear me? Hello, can you guys hear me? Hello. Okay,
Yes.
sorry, my network is kind of okay. Sorry, my network is kind of breaking up. I don't know what's going on. 1 minute, just have to like take a look at this. All right, so I kind of skipped. Yeah, so this is all right. So as I said, the AI and like the AI and the context, right? So I mentioned ChatGPT and the fact that with ChatGPT you can make images, right? For general use. So you can prompt very nice images, but it's not really built to give you like proper production level images. So that's what Midjourney does. So I've given you guys three examples. I've given you guys the general context and general like environment, right? And then I mentioned Midjourney. Midjourney is mostly on images, gives you awesome images, like great quality, professional stuff. But it is not really great with videos, which is what Google View is built for. So you see that each of these uh, platforms with LLMs and all that, like AI stuff, they have their context. And for us, our context is spendings. So when you mean spendings, you have to first of all pull the user's wallet address. That's number one. When you put the user's wallet address, you have to analyze based on the context, right? Analyze the spendings. You can expand it to do other things like maybe check if you're a meme coin trader, how much do you gamble? Do you gamble a lot or do you gamble little? Stuff like that. So another point is you can interact with external systems, right? So we've already mentioned blockchain and other services, which is what our own let me call it Nebula. So what Nebula does is just to interact with the blockchain and get the data for you. Now, um, what is the brain of this AI um platforms and like AI agents and chatbots? So they are called the large language models. So this is your cloud, your GPT-4, all these guys are like LLMs. So just to give like a context. So you have the trained version of the AI. So the AI you use is mostly trained to do something, right? And you can have the general applications of it. You can have the context applied applications of it. And then what enables it to make decisions based on the input. So it's more of like an input. If you give it an input, it analyzes the input you give it and then gives you desired output. So which is why most times if you interact with some AIs, they would actually be like, oh, I'm sorry, I did not get this, or oh, I'm sorry, I missed this. Because most times the input is not really clear or is not sufficient enough to give you the desired output, which is why it's not perfect, right? And which is why most companies are now moving towards things that are clear cut. Well, when I say clear cut, I mean I want to do a video. I know what this video is going to be, you know. So this is like the content of the video. This is what I want. That's straight. That's very straight. So once I get my video, I cannot make changes. Okay, remove this or do that. That's like a definitive tax, and then the LLMs can actually understand, okay, this guy wants the video. They can, in whatever environment that they are plugged into, whatever context that they are given, of course, it should be a video or an image context. That context is what they now achieve the tax and like give you the outputs that you want. Okay, so I think here I will just show you guys something. Let me get this. So I want to get my okay, yeah. So okay, so this is OpenAI. So let because as we're going through things, we would basically okay, you can see like I even made some interactions this morning. I have already did something. So let me just get like the overview. Can you guys see my screen? Yeah. So how do I even see a preview? Okay, yes, okay. That's what I want. So this is one of the platforms you can use, to like build build out your AI chatbot. Okay. So it is quite simple. When you like set up this the account and everything, you get to do some setup. So you can see first of all here, I want to actually highlight something here. So look at this from line 4 to line 7. You would see the code here says the model and then gives the input. All right. And then it's expecting an output. Now, the input should basically work with the context that you defined. Okay. And we don't really want to go deep into context, but you will see, for example, they have like context training here where they say you have to specify your input to be an image and then also look for output. So you have here how to work with input of images, how to like get files, and also how to extend for web search, which is like basically my favorite thing with AI is web search. So I think 2 years ago, I don't think you were able to fetch the particular current data. You get so why? Because most of the AI platforms and LLMs were trained to basically have a predefined set of data. So most of them are like, as we are in 2025, you basically have 2024 data, okay? And then all this changed when they were able to now sort of like start with Reddit, get like fresh information from Reddit, from Google, from Twitter, based on the platform. So I know if you use Grook would give you website, like when you say web search, because you have to actually specify website, and that's one thing that we don't really get. If you want to actually get like current stuff, you have to say do a web search, you know, and then because the context is defined, because that like my point here I'm trying to make is like you have to like define context. You can see in this code here, they said use web search in a response. So that means that whatever context that the AI is designed to work with, once you input web search, it is going to act based on the input. Here, the input is what was a positive news story from today. That's the input. And because you specified in the tools, you specified it to be a web search, it's going to say, this is positive news from today, from maybe from if it's aware of your current location, from your location, this is what happened. If it's not, it can give you global news and stuff like that. So, I think moving on, I think I would share this. This is like platform.openai.com. Can I share links? Is it possible? I think chat. Yeah. So, let me, okay. So let me just drop this. Oops. Okay. So this is for OpenAI. All right. One more thing I want to actually like show here before we move on to the slide is models, right? So these models are trained with like higher features as you go. So we've been using okay, so you see that this is the smartest non-reasoning model for ChatGPT you get, and then you would see another version for coding. So this is like GPT-5. This is GPT 4.1 for like general use. This is GPT-5 for like coding. And most of these things, like the difference between them is, as I said, the context and environment. And most are like trained with different tasks to execute. So if you're basically delving into the AI world, first of all, you can use LLMs, right? They're already pre-made, and just plug it in your product, and then you can use it. Any other thing here that is worthy to note? I mean, there's a lot to do, but we are actually focused on what we want to do, which is like our task. So I will go back to the slide, and then we would basically go to the code, because the code is also here. So we can also do an intro, basically talk about the Solana side, then move to what we are here for. All right, so let me continue. But before that, any questions, any interaction? I mean, I love open interactions, so that I don't become the boring lecturer. So any question, I can check the chats if you have anything for me. So you can just drop it on the chats. Let's give it like 10 seconds. If there's none, then we continue. All right. So I guess there's none. So the next thing here is model context protocol, which is basically the way your AI would interact with real world systems. So here you see these are like standard ways for AI applications to connect to external data sources. In our context, enables the AI agent to securely connect to Solana blockchain. And then, sorry, I always skip this. And then provide structured access to the blockchain, ensure security by defining clear boundaries. So you don't really want your AI agents to send money to random addresses or to do what it's not told to do, you know. So which is what in some building like an applications, LangChain is basically what you use like as a framework to get started building with AI, right? And then while you're working, there are some things you have to define. When you work with MCPs, you have to define, okay, this is what I want. Don't go beyond this. There are other platforms like that, like solves you the stress of going deep into things. Like I already mentioned, Send AI, which we'll look into very soon. So just to like because we have a lot to cover and I don't think we even have much time. Um, just to like summarize this, your MCP is more of like your connection between your real world system, your backend, your blockchain, whatever you want it to work with, and then your application. All right. And for use cases, so this is like my favorite part. For use cases, here in this diagram, you would see students ask a question. The LLM is for understanding, to like understand, okay, what is the input, what is the method that this guy and this person is actually looking for. And methods are like, for example, in Nebula, the method we have is check balance, fetch transaction history, and what else? Trying to recall. Send, like make payment to a particular um address, which is like the other packs that would help you like pay for your bills and off ramp. And then when you have that input and the model, you now have LangChain, which is like what I said, the framework that actually handles everything. And then it takes the blockchain action. So my Solana agent kit is in the middle of all of this to like give the interaction and the interface. And like there is a lot of like step happening. But if you look at the use case, first thing is You can ask, how much did I spend on airtime today? Then the chatbot analyzes wallet transaction. You spent $50 on airtime using Air Bills Pay this month. You're like, okay, maybe that wasn't enough. You can say set a budget alert for next month, $200 for next month. And then the context is an alert. So you can have, if you defined for the AI chatbot to have like awareness of time and maybe access some sort of like reminder kind of thing, you can basically work with it. So I know that when you are working with some meets like Meet and Zoom, you can have an AI to schedule a meet for you. Some people are building this to like you basically tell the AI, okay, schedule this for me, so time. It's aware of the time. It can assess the environment you want it to, which is what the MCP helps you do. Assess the what's it called? Google Calendly. Yeah, Google Calendar. And then your alarm, if so. Well, I'm not really sure of alarms, right? Because these are like system programs, right? So most times they don't really have like deep access to system stuff. And then okay, before we go to the demo, let's just play around a little bit. So this is like all the theory, and we are going to go to presentation. Okay. All right. So right now I'm in Send AI. So let's just look at what we can do with the tools we have. Before then, any question, anyone, before we proceed? Mm. Mm. All right. So let me just get into this. So Send AI is a kit that you can use to connect any AI agent to Solana protocols, right? And Send AI is built okay, the company is Send AI and they built agent kits. Sorry, I always confuse this. And you can use it with TypeScript, you can use it with Python. For our particular use case, we basically used TypeScript, right? And then there are some methods you have to define and some things you have to do. We'll get into it in the code. So it has embedded wallet support. You can have a plugin. You can execute with blinks, which is like actions. And you can also fetch on-chain data. So just to get to the docs, so let's just look at it. All right. So I would also share the link to this. So we're actually going deep into like the main work. Okay, let me share the link to this. Someone asks, what can you say about models in HF? Yeah, Samuel, can you clarify your question? I don't really get that. Hugging face. Okay, I'm not really an AI guy. So most platforms I actually interact with is 1 minute. Let me just get this. Okay, so I just had to check. Let's just go Hugging Face. Okay. AI company building, what's it called? Building the future. Okay, and your question, what can I say about models in Hugging Face? Well, honestly, I've not really used Hugging Face, so I can't really say much about them. Okay. I basically just deal with like the popular ones we have, like OpenAI. But let's just check it out. Let's just check it out. Let's check it out. Yeah, I mean, if you have, okay, I'm actually seeing something that I recommend. If you have AI agents that like for images and videos, then that's the context that is basically built for. You get? And general use models are like OpenAI. I don't even think Cloud is okay. If it's for general use, how about we just check it out right now? So we don't really assume. 1 minute. Let me check how models. I mean, I've not really used it before, so I guess this is hands-on approach. Okay, can I check something? So they have Google, they have Microsoft Vibe Voice, they have Tencent. So this looks like more of models that are built specifically like with specifics to some products. So let me check this Microsoft Vibe Voice. So it's a novel framework designed for generating expressive long form multi-speaker. Okay. So this is for text to speech. And then can we look at what is specific to what we want? Apple voice to speech, GPT, OSS. I mean, this will basically be for general use, but I'm not really sure it's designed for blockchain interaction. Can we check if it is? Does it have the required data sets for it? Okay. Let's see. Entertainment, Facebook. Well, I can't really say much about this right now. Maybe I will actually dive deep into it later and give you guys feedback. But what I know, I mean, that's basically why I chose Send AI, is the fact that Send AI is mostly built to interact with the blockchain, trained to interact with the blockchain. Why? The reason is I want to show you guys something. So you can see here that we can, I don't know if you guys can see the side tab here. Let me zoom in a little bit. Okay. So for the things you can do with Send AI, you can transfer tokens, you can stake SOL, you can deploy a token from Send AI, you can check token balances, you can get token data like you can say what is the current price of Jupe, can you fetch this token for me? You can also create a tip link. So tip link is a platform where you can tip someone some USDC or so. I think they support both. And then the person will just go and like with the tip link, kind of like a link, like claim what you have for the person. You can also fetch market data via CoinGecko. Like you can do a lot of things, right? So this is basically something built for the blockchain, right? And that's why I could not say much about Hugging Face because I've not really dived into Hugging Face and I can't really say. But I know that with this, with Send AI, I can access almost everything that is possible on the blockchain, right? I don't know if I actually answered. I mean, I'm sorry if I could not give you like a proper answer to this. My context is basically blockchain interaction. Okay. So let's just get our hands like into some code, but let's just look at how do we basically get this in. So you install Solana agent kits, and of course, LangChain is enabled here. You know, So we don't go out of context of what we are, what we have on our on our schedule, and what we have to like teach you guys like to interact with. But the reason for me, the reason why I chose this is because it makes it easy to interact with the blockchain. You already have preset data, you already have the limits. And that's why I even said that most times you have to be careful how you deal with LLMs, because you don't want them to like exceed beyond what imagine I have like $20 and then let me even load Nebula self. So I have $20 and I end up telling the AI to pay for data, and then instead of doing that, it does something else. I mean, it can be crazy if that kind of thing happens, right? So with Send AI, the tools and the methods that you design is what you use. So while that is loading, let's just check. So you install this agent kit, then you install the plugins. Let me explain the plugins. This is for token interactions. You want to create a token. You want to fetch the price of the token. You want to maybe what is the example? So you can create from your chatbots. You can also send and receive. Yeah, from your chatbot. And this is for NFTs. So NFTs interactions. This is for DeFi. So staking, uh, lending and borrowing. I don't know if it expands that, but basically for all things DeFi. Miscellaneous is more of like interactions with like protocols. Like you can get your domain name, you can get your I think Mitora too. And then Blinks. So Blinks is so there's this thing that happened last year on Solana where from your Twitter you can like execute transactions on your Twitter. So it's more of like I don't know if you guys know anything about mobile, but when you have a mobile, you can basically from a mobile phone, move to Twitter without leaving your app. So if you're in an app, you can actually deep link to another place in a very smart way while maintaining the context, right? So it's the same method, but with a lot of security and a lot of stuff. So you can from your Twitter buy a token that is shielded on Twitter via Blinks, like ASAP. And you can like you can do vice versa, you can sell. So you can actually build that with Send AI's agents kit. So a basic installation. So here we have, I think anything code should be good when I get the code. So let's just go through this. So this is how you like install. If you want to use a key pair, you can use a key pair. If you want to use, I'll show you guys how I used Privy, and then you put in the plugins that you want. And these plugins will basically give you the methods that are available. Okay. And then this is for embedded wallet, which I'll show you guys soon. And then this is the MCP that we talked about. So you see here that their own MCP and the example that they give is to interact with cloud desktop, and Solana blockchain. So this is for you a way for you to like have cloud to access Solana functionality, and there are a couple of setups you can do. I mean everything you need is here. If you just follow the steps, and you're good to go. But this is not really what we are doing, so we'll get to ours in a bit. Anything else I need to talk about before I move to the code? I don't think so. Let me share this link in the chats. So before we get to the code. Okay. All right. 1 minute. Okay, so for anyone interested in actually checking out Send AI, for me, I recommend using it if you want to do stuff around AI and Solana. The best, because you when you deal with the blockchain, you have all sorts of security to think about. I mean, this helps you to get like started in the best possible way. So with that said, let's check out Nebula because I think it's already fetched. Yep. Apologies for the silly UI. All right, so let me just log out. So can you guys still see my screen? I have some red and white stuff. All right, so this is Nebula. So Nebula is our campus payments intelligence. So analyzes your spendings, takes decisions for you based on your context, and it's like strictly for utility and off-ramp for now. So it's actually not fully expanded to do much, but you can actually analyze your balance. So for our case today, we are working with Privy. I think let me connect to my Phantom. Oops. So here I have my balance. So this is the data set available for the AI to work with. Okay. And all this is actually emitted from the Send AI agent kit. So now with this data that we have, this is the part. Oh, what do I have here? Do I have any? Oh, sorry. So this is on local. I have to check what that is. But 1 minute. Why is that giving me an issue? Thought I had that. Okay. I think let me just go to the code straight since we're actually heading to the code. Just to see. So my USDC is $2. So I can't really do much of it in here. Maybe get some airtime. And this is my soul balance. And before we get to like doing some, I actually want us to do more of deep dive into Nebula in the other session to like show you guys like how to expand the context. But before I show anything like demo and stuff like that, let's just check the code. So I have to stop sharing my screen and share the code instead. Yep. Okay. Why is this not switching? Okay. Good. Okay, so let's start from the first thing. Can you guys see my code or should I zoom in? Let me open some code. Let's start. Is it little? Is it good enough? Anyone?
Yeah, I think it works. It works well.
Okay. Okay. This is okay. Then. So, first things first. What did we build Nebula with? So I have Gil. I have LangChain from OpenAI, LangChain OpenAI. So this is where I get my OpenAI API and then interactions. These are the kits I'm using. I'm using DeFi, miscellaneous, and token. So basically, I'm actually using just token. These ones, like I added it, and then LangChain framework for us to have AI agents interaction and stuff, and then some the React stuff, and then Solana agents kits. Now, first things first, how do you get started? So we're basically just going to do this and then finish up in the evening session. But I have to do like most of the work here. So first of all, you have to get Privy in, which is what we have here, Privy. And how do you set up Privy? You have to set a provider for Privy. So which is basically how do I get rid of this? So you import Privy provider and then Solana. So let me just do a little bit of Solana here. For you to interact with the blockchain on the front end, you need to include what we call providers. So providers are basically telling your code that I'm going to use this. So I want you to bundle it for me at runtime and make it available for me. Without the providers, you can't really use whatever methods or hook the SDK gives. In our own case here, Privy is a wallet authentication. So you saw as I did a demo where I connected with my Phantom. You can also connect with your Google account. You can connect with Discord, Powercaster, Twitter. You can even connect with your phone number or email and password. So, but for the purpose of this class, I did what's it called? Email and wallet. Now, the preview provider is basically bringing of course the app ID that will help you like set up, and then this connection. So basically, preview is like multi-chain. So it's Ethereum and Solana. So for us to like inject Solana into it, you set up and like say you want external wallets, and then this will give you Solana as one of the external wallets. Then you have to connect with Solana. And then here, if you want to create a wallet for a user when they log in, you can say yes or no. I think I'm sorry I did not push a public link for us to test Nebula. Like had some stuff to like clear up. But when it's out, we should be like this evening or tomorrow. You would basically have to create your own wallet when you after logging in, you have to create your own wallet. But I can actually set this to create for user without wallet. So when you log in and you don't have a wallet with Privy, to create for you. But the reason why I want to create, why I don't want to create for anybody that logs in is so that I can control who is just checking it out and who is there for the first time. Do we have questions? Okay, so not for me. All right. Then I set up the appearance, and we're actually on mainnet, so I set up the RPC. So RPC is, let's call it a connection between you, your code on the front end, and the blockchain. So it would get all the information you need, send and receive transactions for you, and make all the connections to the blockchain. Without it, you cannot make connections. And we have mainnets, we have DevNet. Let me see if I have that. Yeah, we have DevNet, we have mainnet, we have testnet. DevNet is where you can actually test out your stuff with no real money. So you can test it with like fake money and all of that. A mainnet is where you actually have the main money, the main Solana with the main value. Testnet is more of like for validators. For the case of this our product, we are using mainnet. So once I'm done, I now have to set up Gil, which is like a package that would help get Solana environment into your code too. So Privy is basically to get authentication and money interaction into your code, but you need the environment to also be enabled into your code, which is what Gil does. So I set up the Gil connection using this. So this is my mainnet RPC. Like it's very basic, right? And then where all this code goes into is layout.txt. So in layout.txt, you have to inject it. So at the top level of your code, you have to put in providers. So that way, at runtime, and then when you have the bundling and everything with TypeScript, you have the providers and the methods available. Now, next thing is okay. Next thing is setup of the AI. So here so you can basically use LangChain. You can use OpenAI. I think there's another one. I think Vercel. Yeah. So these are the Is this correct? Oh yeah. So for Nebula, I think I'm using, okay, I switched to OpenAI, but I think I'm using LangChain tools. So I think this is a mistake. Then you put in the plugins, which is token and miscellaneous. I'll see explain this. And then you get the wallets from Privy. This is to sign and send transaction. And then this is to sign a message, which is what I signed when I was signing my Phantom. You guys did not see it. It's hidden. So the reason why this is here, which is like opposing Gil, so you either use this or use Gil, is the fact that when I was building this, I started with Gil, but I now found out that Solana Agent Kit, it's not compatible with Gil. So I had to like start making changes, which is why I have not pushed the code. So I started with something that is new, but Solana Agent Kit actually works with the old, not really old, but works with Solana Web 3.js. So I have to make changes to it to clean up the code. But moving on, that doesn't stop anything. We fetch our wallets from Privy, and then basically sign a transaction. So if you want to sign a transaction and send transactions, you can call this method. Now, why are we doing all of this? Let me explain why we're doing all of this. If you have a wallet, right, and you want to approve a transaction, you want to send money, let's say in our own case, we want to pay for $2 worth of electricity, you need to make sure that you have the right methods. If not, it won't work. Now, in Solana, when you want to sign a transaction, you have to first of all, construct the instructions, then sign it. So what you use to construct the instructions as well as the whatever you want to do on chain, you do it with wallet adapters. Now, when you use Phantom and Privy, these wallet platforms provide you the methods to call. So you have to use those methods to build your wallet adapter, which is what all these things are here for. These three guys, that's what they are here for. So in our own wallet adapter, which is in line 50, let me pin it. We first of all get the address, the wallet address, which is what is showing in my account in Nebula. This is where I get my wallet address. This is for you to sign transaction. So when you get a transaction and then you sign it, and also for you to sign, you have to provide a transaction that you want to sign, the connection, which is like connection to the blockchain, and then the address. Okay. You can also sign message, which is like a memo. So like you be like, okay, sign this. We can change this to something else. So it's more of like a message, not really a transaction, but it's a message for you to like approve, to like do something. So it doesn't do any balance or money deduction and stuff like that. It's just a message. So we have send transactions. So you can sign and then send, which is what do I have? Yeah, this is which is what this does. So sign and send. So you basically do it in one go. All right. And then the next thing is we set up our agents, fetching the wallet adapter, the RPC, which is like the environment we want to interact with in the blockchain, which is mainnet beta. And then the plugins we want, token plugin, which would help me get all stuff with token. So if I expand this deeply, sorry, I went into the rabbit, so but I want to show you guys something. So here, the things I can do with Nebula, if I define it as an engineer, is I can burn tokens, I can close accounts, I can get wallet address. What else can we do? Okay, yeah, this is what we need. We can fetch price, we can stick dupe, we can trade, can create limit order directly to Jupiter. We can get wallet balance, transfer, like basic things, right? We can launch a pump.fund token, but I'm not going to enable it in Nebula because we students, we don't need to have that kind of context and environment. But yeah, you can launch a pump the fund token. I don't know if I'm still audible, guys. Am I still audible? All right. So can launch a pump the fund token. You can claim a creator fee. So basically, creator fee is like if you create a token, right, you can claim the fee attached to it. Also, I can fetch prices. Pyth is like an oracle. So an oracle is a platform that gives you real-time data from external sources and injects it into the blockchain. So if you want to fetch the price of Brent, crude oils, stuff like that, I think they have like defined data that they push. Okay. They can bond tokens, so you can basically do a lot of things with this guy. I'm not going to enable pump and fund for students. I mean, maybe when you clone the token, you can do it yourself. When you can clone the repo, if the instructors make it public, I'm here to push it. But when you clone it, you can create an degen, right? But if we want to do that, we basically have to like tell the AI to help us a little bit. Maybe set a limit. So I say, Nebula, I want to be spending $2 inside any token that I paste here. Do not allow me to spend past that $2. The engineer, so if I'm building it for you guys, I'll basically put that in, and like the limit should not be more than $2. So because we are working with students before we, do some stuff, some crazy stuff with our school fees and stuff like that. It's not a go hard or go home kind of thing. Like really, you have to design. So that is why, and like saying this now, that is why when you are dealing with ChatGPT, cloud, there are some things you can't say, and it's not aware of those things. It tell you, I'm not designed to do this. I'm not allowed to do this. I think even doing stuff with crypto was actually not like in vogue 2 years ago, last year, until they're now allowed to, because basically it's the future of finance. So they like allow the bots. They can't really give you financial advice. I'm very sure of that. So moving back. All right. I think I've explained this. One more thing we can look at, or actually a couple more thing is, yeah, okay, good. All right. So this is basically the front end, the red and white place that you saw. So I am setting privy to authenticate user and for login. Okay. And then so this is like the front end. I want to show you guys exactly where we are doing. So this is where we connect to privy. So just to show you, you basically call the login for login, and then you call logout for logout. It's as simple as that. And for the AI part is mostly, so this is where you create your wallet. It's not really necessary for us. This is for quick actions. So quick actions are more of like defined buttons that I created that can help you. So you can see the action is what's my balance, show my recent transaction. So it's actually pushing transactions by default, and then pushing balance by default. But you can also have a conversation with the AI. You get, and then campus spending, and then to actually go to our backend soon, so we see the interactions we have with our backend and what's going on. What else? These are like actions that we have. So I think out of the actions we have, I think the first and second one are actually active and working. What else? What else? What else? I'm just trying to. I mean, I'll share this code later so we can have access to it. Uh, um, I think we should just go to the backend, the API code. All right. So this is chat. Good. So there's a lot of code here, right? But let's just go to the most important thing. So this is, am I still audible, please, guys? I always feel like I'm not. Am I audible? Okay. Okay. So let's continue. So let me explain what we have here. So this is basically the main thing that enables enabler. All right, first of all, we have LangChain, specifically OpenAI's instance, and then we have the executor environments, and then the functions. I think we'll actually go deep into this in the evening section, just to like get our hands dirty. So there's no theory and stuff around there. Solana agent kits, which is our main thing, and then create LangChain too. So this is what was causing my issue. So let me just quickly solve it before I get. So here I have create. So I was using something else. That is not what we need. All right. Okay, so let's go back. Why do you want to see my EMV? Why do you want to see my EMV? Ah, God. For practical. I mean, I've already shared, guys, I've already shared Send AI. You can get like clone the code. I've already shared ChatGPT, OpenAI's this thing for like the ChatGPT ID, not ChatGPT, the OpenAI ID for the LLM, right? And then what else do you need? If you want RPC, you can use Helios. I'm not sharing my EMV. I think I have to even delete the EMV self. I think we have really interesting people here. Someone asked a question. How can we do exactly as you have demonstrated? Maybe we can do demonstrations in the evening, right? But without exposing my EMV, maybe we can just like can just check it out and take more. Nobody see my EMV. I want to get someone's question. So Melody said, is there any course for Solana front-end engineering? Like a course dedicated to front-end engineering with Solana, whether paid or free? Yeah, I think we had Blue Shift, right? I think that was one of the people we had. So you can check out Blue Shifts. I'm building Roster Dead Sha. So when it's ready, I mean, we're not really hands-on approach to code right now. So maybe later on, maybe next year, we can actually have like code and stuff. I mean, you can like have fun. Like it's a game you play and then you learn. But for other parts, I think so. My personal advice, Solana front-end engineering is not quite different from um normal engineering, like front-end. So TypeScript, of course, because you have Rust, and Rust is very type-based. So if you're saying Obi is a boy in Rust, Obi must be a boy, and Obi cannot be like, you cannot say Obi is a boy on your typing and then want to make Obi a girl. Engineering wise, nothing else in this context, engineering wise. So it's very type, or you say this color is red. The color is red, and if it's red, then it has to be red. You can't really like shift type. So TypeScript is what's going to help you to like interact with like the program side of things. What else? What else? You need wallets. You have to like be conversant with wallet adapters. So in my own case, I used Privy, but we have like some basic ones that are easy to integrate. One thing about Solana is whatever you need to do, it's very easy to get started on those things via following the dots. So while I've mentioned some places, I've mentioned Blue Shift, I've mentioned Aki. Aki is also good. Maybe we can make a tweet like how to like get all these resources and stuff like that. But one thing I would advise is also get your hands like into the main thing. If you have your basic TypeScript knowledge, you know how to use Next.js or Vite or create React app or like all those things, you can just get a code. They are open source codes on Solana. You can just go to GitHub, search whatever you need, and you'll see like someone has done it and it's open source. You can just clone that one and then start interacting with the code, and like you make changes, you make corrections, you learn, and before you know it, you would be a good front-end engineer. So I don't know if I answered your question, Melody. Uh, please ask if it's not clear. So moving on. I mentioned that for purposes of like what we are doing here, we are basically focusing narrowly, we're focusing like on two key products like Airbus and Patch Cache. Airbus is for utility, Patch Cache is for off-ramping. You can expand this as much as you want via like whatever spending students can actually interact with. So still not sharing my ENV. For anyone that wants to ask for the ENV to see the address, I'm still not sharing it. Okay, so what's the first thing we do? We basically like set up like the checks and errors to like make sure that this is not getting bad code. And then we get the wallet adapter to like get the data we need, but not like allow some things. And then like other stuff that I have here. I just want to show you guys the main thing. Okay, yeah, good. This is the code for fetching balance. So you can see here, I'm trying to check USDC balance using sendAI's method. So this is USDC mint address. Mint address is more of like identifier for the token. So for each tokens on Solana, they have identifiers to it. Okay. And then this is to get balance. We feed in the agent and then the identifier, which is like token mint, and then it will give us our balance. And this is via a chat. So if you can see here, I defined an input. So this is via a chat. An input would give us the output. Let me check if while we're on this, let me check if I can pull Nebula and maybe run a sample. I don't really want to, because I want like we have actually spent a lot of time. I want to give rooms for questions, or in the evening we would actually convene and do more testing. So while I am trying to 1 minute, I just want to check if I can show you guys a prompt. My network is not responding. Hmm. Oh, this was shut down. Oh, sorry about that. Okay. All right. So yeah, so the send AI, I think this is actually something important. I actually encountered an issue with this. So send AI, like they push some methods for you to use, which is like why I like it, because it actually sets defined things for you to do. So we can take balance action, you can check token balance, you can check wallet address, you can fetch price, and like there are more, they're like 2,000 of actions you can do. But this is what I fetched to like give you guys the context. This is what I'm using. This is where I defined my context. And it won't go beyond this. Okay? It won't go beyond this. You can expand more. I mean, we can say, let me see if I can find that. What was it called? What's it called? I'm trying to see if I can get okay. I want to see where they actually defined all the actions. Sorry if I am yeah, the pump phone stuff. Yeah, I think this is it. But it is a lot here. I think I would actually have to calm down and look for it. But let me just remove this. So I need to find the actual definition of the tool to now use it. Then this is what I have. This is the context I defined. So which is what I'm using right there. So I can get balance. Let me close this so we can see. I can do campus analysis. So we can analyze the spending. These are like definitions. We can get the transaction history. That is what I'm looking for. All right. I think I should explain this. So this is where I inject the LLM into my code with the I think OpenAI model, and then I have my env and the model name which I defined here. You can change this to other models. Let's see. They did not specify if you can change to other models. Can we change to the models are string? Do we have? Oh, okay. They did not really specify the models we can switch to, but let me just go back to what I was using. And then this is where we execute all that we need. And so why this is I'm just trying to see if I can get the environment to like show a sample of something before we go. All right. Let's see. Yeah, so while I'm trying to get this up, can any questions, anyone, any questions you can ask? I think we are open to questions. You can unmute yourself and talk. We have a few minutes to go. I think 10 minutes to go. In the evening, we'll focus on Nebula completely, and I show you guys how it works. So any question? Anyone? Come on, guys. Ask. Ask me, ask me, ask me, ask me, ask me.
You guys, it's time to ask questions. If you have any question you'd like Daniel to answer, this is the time to ask before we get to the evening session, and there's a lot more hands-on. Whatever you don't understand from like this introductory workshop, you can ask now. Are there any questions? Okay. It seems like there are no questions, Daniel.
Yeah,
Okay.
we have
All right.
we have
Yeah.
people that are active and they want to
Okay. I think
view. Yeah.
we have a question now. Adela said, can we do escrow with Send AI?
Escrow. Can you explain? I do like unmute. Explain. Like this is
Well, I'll come up
interesting.
and explain.
I'm currently in a noisy place. I'm at the airport. So I don't know if you can hear me.
Yeah, we can hear you.
Okay, so with launch tokens this using Sunday, open up one that is integrated in similar. So I'm thinking about when you are trying to probably like as a student now, and then you're trying to probably stand like as an intermediary for more students transactions. It's possible you can initiate an escrow protocol using the same AI without having to work with Rust and all.
Okay, okay. I think that's possible, but it depends on the context. What would the AI do for you in this?
So
Because that's
the AI is meant
yeah,
to
go
like
ahead.
hold the funds, right? Until both parties agree on something. Probably that they want to probably buy or something, right? And then both parties have to agree before it releases the funds.
Okay, I think you can build a custom AI chatbot to handle escrows, but the AI is not going to handle the money. So how you do this is, first of all, if you can basically take any Vault Rust code. There is no how you would do without Rust, right? Let me explain why. When you start dealing with funds, you need a system that is strong and like tested to handle money. And Rust and Solana, Rust and Solana can actually help you do that. So you can basically get an anchor code that has an escrow and then design it to work specifically as you want, and then you bring the code, the IDL and stuff like that into your front end or like into your AI chatbot, right? And then see how this would work. Let's say we want to do an escrow now. I would enter the escrow. Yeah, you can't, because the reason why it's there is because of security. Honestly, it was security. But it's fun if you add an AI chatbot into this. Why? If I enter the escrow and I set my conditions, it's going to be an input. Our method is going to be like escrow. So you would basically have to like design a custom method and a custom tool, and then you set the. Let's say I'm the person that is giving, and you're the person that is taking. So I basically give like the conditions and everything, and then you actually accept, and then the money will be locked. So what we'll just do is we'll now tell the AI to send the money deposited into the vault, the smart contract, and the program's vault. So it will now send it there, and then the AI should be aware of timing. So the context should be aware of timing, and then with that time awareness, we can now like come back when it's done, and the AI will automatically just like when the conditions are met, to just release the money. It's an overkill, but it can work if it's like students curated. You don't have to like interact with Rust and everything. You get, but that's one thing. I mean, you can check it out. It's very easy to actually do things around AI. Yeah, but you can't really escape Rust. If you want to build something substantial on Solana, you have to actually understand it, as an engineer, So that's like also it's not much that you would write Rust to be a good Solana engineer. You can actually be good at front end, like very, very good, and you still actually have your way around Solana. But for you to like do stuff with money, you need Rust. Any other question? I want to do a sneak peek before I go. So any other question before I do my the reason I want to do is actually like get people in to come the evening session. So at least in Nebula. So let me switch my screen to Nebula. So yeah, so I'm in the AI chats side. So I'm going to use the quick side. And that's not what I'm going to do. I'm not going to send the money. I'm just going to show you how the AI is aware of the context. How did you encounter issue? I just tested you now. Nah? So let me just reload. Maybe this is down again. Okay, so let's see. Pay for electricity. So basically, how we train this is to, before you make any payment, you have to tell it to check your balance, and then when it's done, it would basically ask you for the amount, and then when you input the amount. So now, one thing I've not actually done is to actually figure out if we're going to directly send to the platform for airtime. I have to speak with the engineers over at Airbills and the engineers over at Cash to see how they actually handle on the granular level, how they handle like stuff like this. So Nebula would now have the ability to directly interact with Cash and directly interact with Airbills, and then as a student, you just come in, you just log in, and you connect your account and say, pay for electricity, you check your balance, ask you how much, impute the price, and then it will run it for you ASAP, and you see your money. So in the evening, we can work on basic stuff like check balance and an analysis. That's what we can do. And then maybe I'm very sure I would actually take this serious, try and build it out so we can actually now do for electricity and like off ramp. So thank you guys for coming today. Yeah, that's one thing I have to actually like contact with them. There's a way around it. Oh, someone said screen is blank. Sorry. Uh, how can I solve this now? Someone said you can say it. So in the evening, just come. You see the magic that we did. Just come in the evening. Yeah. So thank you guys for today. Really amazing. I'm sorry if I drift away sometimes. Uh, but in the evening, we would actually focus on Nebula completely, and then we'll do some basic stuff. I think we can actually find the way, because what I want to do right now is find a way to like maybe see if I can simulate or try. There is a risk I can try to like execute with $0.5, execute air bills or patch cash, $0.5. So, but I will try it. But if it doesn't work, the $5 is lost. But I will try it, and in the evening we'll know if it's possible or not. So thank you guys. It was really nice having you guys here. I look forward to see you guys in the evening.
All right, Daniel, thank you very much. We enjoyed your session. Thank you for your time and the effort you put into this session. As everyone has been saying, it was a lovely session, true and true, and we hope that the evening can also be just as good as this one. Thank you once again. We really do appreciate this. Okay, guys, so I think we've come to the end of the morning workshop, and I hope you guys had a lot of fun learning from Daniel and Mario. Yeah, thank you very much for attending. You guys can go about your day now, but please don't forget about our evening session by 6 p.m. We are going to have Daniel again to take us through simulating Nebula and putting the final touches. Also, guys, don't forget about our social media contest, whereby you guys post and tag Solana Student Africa, the Solana account itself. You can tag Daniel, you can tag Mario, and just talk about what you learned and how it would impact your life. So there is a prize to be won for whoever like does the most posts, but at the end of the day, it's all about you sharing what you've learned and having like proof of work about the concepts you are learning and what you can do with them. So remember to do that, and yeah, see you guys later. Take care, everyone. Half of the half of the hackathon prize money. No, no, it is not half of the hackathon prize money, Collins. But it is a nice it's also just as good. Yeah, let's just put it that way. Collins, we are not negotiating the price for the contest now. Please leave me alone.
Yeah, also those that are streaming on Twitter, LinkedIn, YouTube, they should also join back in the evening by 6 p.m. so you can get your full package of what we had this morning. So don't forget
Yeah.
to join us by 6 p.m.
All right. Yeah, so that's it. Don't forget to join us by 6 p.m. The evening session is going to be dope. And yes, it is proof of work which we are focusing on right now, Collins. Forget about the money. Do it for the proof of So what, let's just end this. Daniel, thank you so much for us again. We look forward to seeing you in the evening. All right, everyone. Have a lovely day.
Yeah, bye guys. Bye.